Hello and welcome to the Earth Networks 2021 Hurricane Outlook webinar. We'll be getting started in just a few moments as we wait for everyone to log in. Hello again, this is the Earth Networks 2021 Hurricane Outlook. Thanks for joining us today. I'm your moderator, Anna Porteous, Director of Marketing here at Earth Networks. Before we get started, I'd like to go over a few points. We will be taking questions at the end of the session. If you would like to ask a question, please use the question section on the GoToWebinar control panel. If you have questions or need more information after the webinar, please email us at info@earthnetworks.com and we will follow up. You are in listen-only mode, and this is to minimize background noise. This webinar is being recorded. All registrants will receive a link to the recorded webinar and slide deck in an email we will send out after today's session. If you're having trouble hearing, please make sure your speaker volume is turned up. You can also listen to the audio by selecting Join by Phone in the audio section of your control panel. And if you're still having issues, close the application and try to rejoin. Finally, feel free to let us know if you're having any problems and we'll try to help. We are Earth Networks, a member of the Advanced Environmental Monitoring family of companies, and we operate the world's largest proprietary weather observation and lightning detection network. Our vision is a safer and more prosperous world, and we help global organizations automate decisions through weather intelligence. Hurricane season begins on June 1st and lasts until November 30th. Each spring, our meteorologists analyze trends and all kinds of weather data to create the Earth Networks Hurricane Outlook. It's a collaborative effort backed by this amazing team. And here is the Earth Networks 2021 Hurricane Outlook team. We provide 24/7 custom threat forecasts and seasonal outlooks like this one for major sports teams, schools, aviation, and enterprise clients. Today's webinar will be presented by Earth Networks meteorologist Alyssa Robinette and Anthony Sagliani. Alyssa joined Earth Networks in 2016 as a meteorologist. Her responsibilities include providing short, medium, and long-range forecasts for various clients, creating written and graphical content for the general public, and performing data quality review. Anthony Sagliani joined Earth Networks in 2015 as an operational meteorologist. He produces custom forecasts for a wide range of clients in the US and around the world. And now it's my great pleasure to hand it over to Alyssa.
All right, thank you, Anna, and thank you everyone for joining us. I'm going to first start by doing a review of the 2020 hurricane season. So there were 30 tropical named tropical storms, and this set a new record, which the previous record was 28 set in 2005. There were 14 hurricanes, and this is the second highest on record. The number one was 2005 with 15 hurricanes. And then there were 7 major hurricanes, which is now tied for the highest most, which was with 2005. The National Hurricane Center ended up just actually upgrading Hurricane Zeta within the last day or so, and it was first rated a Category 2 system, but it has now been upgraded to a Category 3, which makes it a major hurricane after their post-analysis. Here's a look at all the named storms that occurred in the 2020 Atlantic hurricane season. And not only was it record-breaking in the number of named storms in major hurricanes, but it was also record-breaking in the number of U.S. landfalls with 12. The previous record was 9, which was set in 1916. Just to compare, 2005 had 7 U.S. landfalls. Louisiana was the first state to have 5 landfalls within a season. This included Tropical Storm Cristobal, Hurricane Laura, Tropical Storm Marco, Hurricane Delta, and Hurricane Zeta. We saw 10 named storms form in September alone, which is the most of any month on record. We also had 10 systems rapidly intensify. Here's a look at all the tropical watches and warnings that were issued along the Atlantic coast in 2020. This does include storm surge watches and warnings. The graphic mentions through November 15th, which is the last watch or warning when it expired. We see that every coastal county except for 2 in Florida had some type of watch or warning issued this season. And that was the 2 counties that were not included were a portion of the Florida Panhandle near Tallahassee, and that was Wakulla and Jefferson counties. Taking a look at the verification of the 2020 hurricane outlook, Earth Networks issued 2 outlooks. The first one was issued in early May, and then the second one was issued in mid-July. We were already watching Tropical Storm Arthur during the first outlook, and then up through mid-July, we already saw 6 named storms develop. Just seeing how the season was trending and it being even more active than we originally thought, we decided to re-examine the most recent data and reevaluate. Taking a look at ACE, this stands for Accumulated Cyclone Energy, and it is a measure of the overall tropical season. It factors in intensity and duration of named storms. Hurricane Laura, for example, was a storm that contributed a good amount of ACE to the total value for the season, as it was very strong and lasted a while. And so the ACE values, we first predicted 150. We upped it to 175 in July, and the actual was 180, which is very close to both those numbers. For named storms, we first originally had 16, which is above average to begin with. Then we upgraded it to 22, and we saw an actual of 30. For hurricanes, we first had 9 in our forecast. We increased it to 11, and the actual was 14. And then for major hurricanes, we had originally 4 in May, 5 in July, and the actual was 7. Taking a look at the climatology of Atlantic tropical cyclones, we see that occasional storms develop before or after hurricane season. And the typical hurricane season runs June 1st through November 30th. There is some talk of moving the hurricane season start date earlier, just because it is possible for these systems to develop, and that would be similar to the Eastern Pacific season, which runs May 15th through November 30th. But for right now, the official hurricane season runs from June 1st to November 30th. We see that the peak activity occurs in early September, and there is typically a second peak early October. And August through October is the primary time for major hurricanes. A new 30-year average came out this year, which covers 1991 through 2020. And this new average has 14 named storms, 7 hurricanes, and 3 major hurricanes. This is compared to the 1981 to 2010 average of 12 named storms, 6 hurricanes, and 3 major hurricanes. So this graphic shows the 30-year moving average of storm counts starting in 1880 and going all the way up through 2020. And we see that there is generally an upward trend as time goes on, but there are these minor peaks and valleys that occur every 20 to 40 years. This is most likely due to long-term climate patterns such as the Atlantic multidecadal oscillation. For our outlook, we are going to use 1950 through 2020 for the climate normal to account for these long-term climate patterns, and hopefully it'll give us a better scope of possible seasonal activity. These graphics show the typical tropical cyclone formation between June and August. And in June, we typically see tropical systems developing in the Gulf of Mexico and Caribbean Sea, though it is possible for some development off the southeast US coast. There are also the possibility for stalled fronts over the US that can sometimes lead to impromptu tropical cyclones. It is possible for Florida to get tropical storms very early in the season just based on where they are developing. By August, we see that the activity becomes more widespread and frequent across the Gulf, Caribbean, and off the East Coast. But there is also a significant amount that develops off the coast of Africa and along the equator. This may be due to thunderstorms developing off Africa and moving westward. June typically has a limited time of development since they form so close to the US, which leads to weaker storms and a lower ACE value. Meanwhile, tropical cyclones that develop in August are usually further away from land, which means they can last longer and become more intense and lead to higher ACE values. We also see that the number of cyclones developing more than triples in August compared to the number in June, which in June it is a number of 125 named systems, and then in August it jumps to 451. And then moving on to September and November, we see that the tropical cyclone formation peaks in September with a number of 630 developing named systems. And there continues to be a tremendous amount forming along the equator, Gulf of Mexico, Caribbean Sea, and off the southeast coast. Formation drops rapidly from September with a number of named storms of 630 to November, which is 89. Formation diminishes towards Africa and the equator and is generally focused in the Caribbean Sea by November. And once again, with the closer proximity to the US, these systems are usually weaker. The jet stream also over the US starts to become more prominent by November, which can force formation out into the central Atlantic Ocean. Here's a look at the total US hurricane landfalls between 1900 and 2010. We see that the highest number occurs in southwestern Florida and the Florida Keys, though southern Florida, the central Gulf Coast, and eastern North Carolina also have a high number of landfalls. This includes places like Houston, New Orleans, Miami, and the Outer Banks. As we go farther north towards the Mid-Atlantic and New England, there are less landfalls, and this also does include the northern coast of the Florida Peninsula and into coastal Georgia. Moving on to the elements of the 2020 Atlantic hurricane season, we had two main key predictors for this outlook. The first was El Nino or La Nina, and it is also known as the El Nino Southern Oscillation or ENSO. And then the other one was the Atlantic Multidecadal Oscillation or AMO. So ENSO is a periodic cyclical warming and cooling of the equatorial Pacific Ocean. With El Nino, we have warm waters that spread east from the West Pacific towards South America, which leads to more convection or rain and thunderstorms along the equator into South America and parts of North America. With La Nina, we see cold upwelling or the rising of cold water just off the coast of South America, which sometimes could spread west. This forms the warm pool of water to remain over the West Pacific and leads to more convection in the West Pacific and less convection for South America and parts of North America. For a neutral phase, this is just a transition from El Nino to La Nina or La Nina to El Nino. Here's a look at the long-range forecast models that predict the phase of ENSO. And so most of the models forecast neutral ENSO for the 2021 hurricane season. There are an overall large spread and range of possibilities, such as some outliers have the neutral phase trending towards an El Nino. If ENSO were to trend out of the neutral phase, there is a slightly better chance, though, for La Nina to develop compared to El Nino. Here's the typical impacts for La Nina, since it is possible that it trends this way. And so there typically is weaker vertical wind shear, which means changes in wind speeds and wind directions throughout the atmosphere, and weaker trade winds in the Atlantic. There also is typically less atmospheric stability. And so all of these combined technically most likely lead to more hurricanes. Here's a look at the accumulated cyclone energy, which I talked about a little bit earlier. Once again, this measures the total overall seasonal activity, and it factors in both intensity and duration of named storms. And so the mean ACE from 1950 through 2020 is 104. Just a reminder that the 2020 ACE value was 180. While there was a record-breaking number of named storms, that does not mean that the ACE also has to break records. One major long-lasting hurricane can really bump up ACE, while weaker, shorter tropical systems can keep ACE values low. So the most recent years with ACE values greater than 200 were 2005 and 2017. And then 2013, 2014, and 2015 were the most recent years with ACE values less than 100. When we compare the ENSO phase during August, September, and October to the ACE values, we see that La Nina events favor higher ACE and more active seasons than El Nino. For example, a strong Nina usually produces ACE values between 150 and 175, while a super Nino is generally between 50 and 75. Note that a neutral phase does not mean it's not important or should be ignored. It's just a spectrum from Nina to Nino. Even a warm neutral compared to a cool neutral leads to slight differences in the ACE. Historically, a warm neutral produces around 75 to 100 ACE, while a cool neutral leads to ACE values of 100 to 125. The most likely scenario for 2021 is a cool neutral phase. Looking at the second main factor, the Atlantic multidecadal oscillation, this considers just sea surface temperatures anomalies in the entire North Atlantic Ocean. The graph shows the AMO value since January 1950, and cycles typically last 20 to 30 years. Since 1995, AMO has mainly been positive, meaning that they have warmer than average sea surface temperature anomalies. The 2021 AMO values so far are 0.14 in January, 0.15 in February, and 0.12 in March. Just to compare, the highest value since 1995, since we've been in this warm phase, is 0.52. Generally, values between 0.1 and 0.25 equal a moderate AMO. So both AMO and ENSO modulate tropical activity. When we combine ENSO and AMO, we see that a clear pattern emerges. Stronger La Ninas and positive AMOs favor more active seasons. For example, a strong La Nina and a positive AMO typically produce 150 to 200 ACE. Stronger El Ninos and negative AMOs favor more inactive hurricane seasons. A strong Nino, for example, and a negative AMO typically produce 25 to 75 ACE. There's once again major differences in the warm neutral versus cool neutral. And this is considering a cool neutral and a positive AMO for this outlook. And so that would typically produce ACE values of 100 to 150. This would be considered generally near to slightly above average if the mean is 104. I will go ahead and pass it over to Anthony now, and he'll talk more about the forecast methodology.
Okay. Oh, thank you, Alyssa. So as Alyssa said, I'll be going over the forecast methodology and our official forecast for the 2021 hurricane season. So as we learned from Alyssa, ENSO and AMO are certainly two of the most important indicators as to what kind of hurricane season may be ahead. But ocean-atmosphere linkages are complex, and there are additional relationships that advanced techniques like machine learning may be better at working out. For this reason, debuting this year, we have developed in-house neural network and regression models to help aid us in forecasting Atlantic hurricane seasons. So our neural network model is based on 41 years of data spanning 1980 to 2020. We use 5 different predictors that incorporate both the Pacific Ocean and the Atlantic. The neural network is designed to be run during the month of April, and it predicts seasonal ACE based on those 5 predictor variables. We then use a series of Poisson regression equations to go ahead and forecast the number of named storms, hurricanes, and major hurricanes. And once we run the models, we combine the results of the models with analogs, which are years with similar expected weather patterns that are chosen by the tropical forecast team to arrive at a final forecast. Now, most of the predictors that go into the in-house models involve ocean water temperature anomalies in key locations in the Atlantic. This graphic shows the average water temperatures that occurred in the North Pacific and North Atlantic during the first 3 months of this year. You can see that water temperatures are in the Gulf of Mexico, Caribbean, and much of the deep tropical and subtropical Atlantic have been near or slightly above normal. You can also see that water temperatures in the central and eastern equatorial Pacific have been below normal as La Nina is slowly weakening. Next, we will take a look at the C3S climate modeling ensemble for forecast sea surface temperatures from July through September. The C3S combines climate model outputs from government agencies all around the world, including ECMWF, NOAA, NCEP, UK Met Office, etc. And it is a good one-stop shop for getting a handle on a large amount of information. In this image, we see that continued near to above normal water temperatures are expected across the Atlantic in the key areas we discussed in the last slide. The C3S is also showing near to slightly below normal water temperatures over the central and eastern Pacific Ocean, suggesting neutral ENSO to even weekly La Nina conditions. Now, another important indicator that is worth looking at is what the C3S ensemble is showing for rainfall trends in sub-Saharan Africa for the July to September period. So this is useful to understand because the rainfall patterns shown could indicate either enhanced or suppressed African easterly wave activity. And since African easterly waves account for a significant percentage of hurricanes and major hurricanes during that crucial August and September period, it is a good idea to get a sense of what could happen. So in this case, the C3S is showing above normal rain across all of sub-Saharan Africa, which may very well suggest consistent and numerous African easterly waves. So based on the observed sea surface conditions and climate model data discussed in the last several slides there, the team arrived at a total of 9 analogs that match the likely conditions to be observed over the course of the upcoming hurricane season. Many of the chosen analogs suggest an active season is ahead. The analogs show a mean ACE value of 118.3, a total of 15 named storms, 7 hurricanes, and 3 major hurricanes. Our in-house neural network is predicting an ACE value of 133, and the regression models show 16 named storms, 8 hurricanes, and 3 major hurricanes. And as you can see, these values are very close to the analog averages that our team chose. So our final forecast slide, we have the typical normal values during the last 71 years, and then we have what we are expecting to happen for the 2021 season ahead. And we are forecasting a seasonal ACE value of 133, plus or minus an error range of 58, and that is 1 standard deviation. We're expecting 16 named storms, plus or minus an error range of 4. We are expecting 8 hurricanes, plus or minus an error range of 3. And finally, we are expecting 3 major hurricanes, plus or minus an error range of 1. And based on climatology of the last 71 years, this forecast computes to a 55% chance of an above normal hurricane season, 30% chance that the hurricane season ends up being near normal, and only a 15% chance that the season ends up below normal. And in case you were wondering, based on these numbers, there's only a 21% chance that this season ends up as busy as 2020 was. Also new for 2020, we are including probability of exceedance charts to help better convey uncertainty in the forecast and to enable users to more accurately assess risk. So this first chart represents the probability of a given annual ACE value being exceeded. So the black line is the probability of a given ACE number being exceeded based on the 1950 to 2020 climatology. And the orange dashed line displays the probability of ACE exceeding a given value based on our forecast of 133. So for example, this year there was about a 12% chance of ACE exceeding 200, but a 72% chance that the ACE will exceed 100. And similarly, this second chart shows the probability of a given number of hurricanes being exceeded for this year. So the black bars show the probability of a given hurricane count being exceeded based on the climatology. And the orange bars show the probability of a hurricane count being exceeded, given our forecast there of 8. And again, for example, this year there was about a 19% chance of the number of hurricanes exceeding 10, and about a 70% chance that the number of hurricanes exceeds 6. So these last couple slides here, I won't go into too much detail. Just be sure to take a look at them when the slide deck becomes available. But just to go over them quickly here in slide 32, we go over some technical definitions and information regarding the forecast and our models. Slide 33 shows how well our neural network model performs in hindcasts. That is how well the model forecasts backwards in time, basically. And the Pearson correlation coefficient between observed and hindcast values is R is equal to 0.77. And so this indicates a significantly skilled model. Slide 34 here shows the geographical locations and names of the variables and predictors that go into our models. You can see they encompass this whole range of the Pacific and Atlantic there. And lastly, slide 35 just shows how the neural network model ranked the importance of each of the predictor variables. And you can see that since the July, August, September, October ONI value is expected to be pretty much neutral, the neural network model is not giving it much importance. However, the tropical North Atlantic variable for July, August, September is given a lot of weight, since that is the waters there are expected to be above normal and there's no impacts from ENSO. So that's our 2021 hurricane forecast, and now I'll turn things back over to Anna.
Thanks so much, Anthony and Alyssa. So now's the time for you to ask questions. We are running up against the bottom of the hour, but we do have a little bit of time for questions. So I just wanted to let you know that we have another Outlook next week, our summer Outlook, and we invite you to participate in that one, and you can register by going to the link in the chat below. So I'm just going to look here to see what the questions are. And one question was, can you email us a copy of the slide deck? Yes, we will. We'll send that out with the recording. The next question is, what could make this hurricane season be less active than what the forecast shows?
Okay, well, one thing we have to keep an eye on is some above normal water temperatures lurking in the subsurface of the equatorial Pacific. Current climate model data shows that this will not pose any risk to the forecast anytime soon, but there is a documented spring predictability barrier that exists in climate modeling of ENSO during April and May. So the speed and magnitude at which this warmer water works its way to the surface may have an impact on if and when El Nino develops down the road here. And while the probability of El Nino for the most active part of the hurricane season, which spans August through October, is very low, if it were to develop, there could be an impact on late season activity, which may cut down on numbers overall.
All right, the next question is, what was the reason that they're wanting to move the hurricane season start date again?
So,
Alyssa, did you want to answer that one?
yeah, so basically, there has been several times when we do see some of the named storms develop before June 1st. And so, it is possible last year, there was a couple, like I said, we were already watching Tropical Storm Arthur when we issued our May outlook. And so we've just been seeing that, it's kind of becomes almost standard for a couple storms to develop before this. And the Eastern Pacific season does begin earlier. So it is a little bit confusing. And so it almost would kind of make sense to maybe match them up since they both tend to start a little bit earlier than June 1st.
Okay, thanks for that. The next question is, are Greek names all retired? Were storms retired last year?
Well, they learned an important lesson, and that is that they're not going to be using the Greek alphabet anymore because of how confusing it was to people. I'm not totally sure if they ended up retiring any storms. Certainly, the names were worthy of being retired. And actually, now that I think of it, I think they did retire some Greek alphabet storms last year, and that also has to do with why they are not going to be using the Greek alphabet anymore going forward.
Okay, I know we're over. We have time for one more here. There's one more question. Is there a higher chance of hurricane landfalls in any one location over another along the U.S. coast this year?
Sure. So this year we aren't seeing any one area stand out more than another. Keep in mind that the most climatologically favored areas of seeing tropical activity in any given year is, South Florida, the central and western Gulf Coast, and the Outer Banks of North Carolina. So also, though, it's important to keep in mind that we are expecting above normal tropical activity this year. And because of that, those locations do have an enhanced risk of tropical activity this year, just because, the probability is higher in general with an above normal season being expected.
All right, well, I'm going to leave it there since we're 4 minutes over. If you do have any additional questions, feel free to send those into info@earthnetworks.com and we'll follow up. I invite everyone to join us next week for the Summer Outlook. And I'd like to thank our presenters, Alyssa Robinette and Anthony Sagliani today. And I hope everyone has a wonderful rest of their day. Thank you for attending.
Thank you, everyone.